Hope some more will join. 10. Environmental management and clean production. Last week, topic we have used can you remember? Is this the last slide we have discussed about the energy efficiencies, efficient use of energy? මතකද මේකද අපි ගිය සතියේ කෙරුවේ? කතාව කියන්න පුළුවන්. Heat, work, energy, environment, clean energy. So these are the keywords we have put for last week discussions, and we have realized that if we take some processes, we took cooking process. So we apply heat, but not all the heat become useful for the cooked rice, cooking process, cooking rice. So there is a loss, and there was a useful heat. So always there is a loss. That's why we have an efficiency. Ironing process. Even when we iron, we can see that there is a usage of heat. That is, electricity converts to heat energy, but not 100% heat is fully used, but there is a little loss of heat to the environment as well. So this is the process. Ironing process. Even our the thermostat or the heat, the settings are not that optimal, and somehow we can see it is not purely 100% using of the available heat. That is a portion as a loss, and of course then the energy balance, when you have the heat in Q in, and when you have a heat loss Q loss, the balance is the heat of the useful one. So in other words, you can see here the Q loss is Q in minus Q, the useful heat. Okay, useful heat. Q, you can see here use. Okay, Q useful. Q net or Q useful. You can see here Q useful. So that is what we have learned. Useful. Okay, Q useful. So this is what so Q instead of Q net, we can write as useful. Q useful. Q useful is there. So that is how it is. Energy balance. Okay, energy balance. Same way අපි නිකන් බත් පිඟානක් කන එක බලමුකෝ බත් එකේ තියෙන. එතකොට බත් පිඟානේ ගත්තාම මේ බත් පිඟානට ආපු ටිකයි ඊට පස්සේ කාපු නැති ටිකයි ගත්තාම the balance is the කාපු ටික. Rice you ate, rice in the plate initially minus the waste you are throwing away without eating, the balance is the rice you have eaten. Okay, the balance. Same way here, the energy also there is a balance. So this is even can be a thermal balance or heat balance or energy balance, whatever the terms, it's okay to use. Okay, and you can see the efficiency term as well. Okay, yeah, good. So instead of Q net, yeah, Q use Q net is the common term you can use. Q use Q net or whatever. Okay, so Q loss is not possible to be zero. Yeah, that's right. So even in engine it is the same. It is not possible to use the energy in completely to produce work. In car engines, there should be losses. The loss means loss of energy portion from the available, the initial energy available. Okay, so Q means the heat or energy. W means the work. Okay, I hope this is okay for even for food and IM students. I hope this notification is okay. Okay, I believe it's okay. So let's say we will take some thermal processes today because we couldn't complete the piece of the for our subject area we worked on last week, that is heat, work, energy, and also about the environment and clean energy. So let's say now I'm going to use the familiar diagram here, Q in, Q loss. Okay, and here instead of engine, I will put here as thermal process. Okay, thermal process. Thermal. Of course, even in engine, a thermal process is taken place. Thermal process. Okay, thermal process. So, very interesting. Yeah. So this for the general. So this is not about engine, but in general. This is example is general, can be any thermal process. Okay, any thermal process. Thermal process. Okay, interesting. Eh? That should be very interesting. So this can be engine. This can be cooking rice. This can be ironing clothes. Okay, ironing clothes, whatever. Even in ironing clothes. So when you use the hot, this iron, okay, hot iron, you apply this pressure with the heat, you can see the clothes. This irregular shape comes into regular shape. Somehow comes into a regular shape with the pressing and with the heat. Okay. Even sometimes you add moisture as well, the water, steam. So actually the output here, generally, see, let's see, even iron you have to apply with the pressure as well, ironing about iron. And it's a very fine surface underneath. So you move the iron with force. So you can see the dress becomes no wrinkles and it is, we call it ironed. Yeah. So this thermal process output is something we would say it has some mechanical aspects of the output. Okay, also possible. Okay, W, there should be some work done. Okay, there should be some work done. Somehow there is a Q loss. So this should be W net, or even can be, let's say, instead of W net, it's okay for us to use Q net. Okay, instead of W net, we can use the output can be a heat, or can be a combination of work and heat as well. Okay, can be a work and heat as well. Okay, so let's say now we are going to discuss some thermal processes. So that is the point now. Okay, so you have Q in and also you have Q loss. Okay, and the balance is something that is the useful. That's the useful. Okay, so you have Q in and you have Q loss. Then you have W net or Q net or Q useful. So let me consider this. In general, okay, in general, why am I going to discuss this? The reason is thermal processes are extremely important when you talk about cleaner production, because your energy types, mostly you will see thermal energy interactions are there. Thermal energy interactions are there. That's why thermal energy interactions are there. So we are going to discuss some thermal processes. Okay, we are going to discuss some thermal processes. Okay, thermal processes. Thermal processes. Okay, let's see. If you take industry-wise, let's see, or services-wise, yeah. We will start from simple. Kitchen. You will see many. Okay, kitchen. At the kitchen. Okay. At the kitchen, you can see many thermal processes. Okay. Many thermal processes. Many thermal processes. Okay. You can see many thermal processes. Many thermal processes you can see. Many thermal processes. Okay. I'm not going to describe. Okay. At home, some more. At home, some more processes you can see. So when it comes to kitchens, how many kitchens? Millions. Millions of kitchens, not just one. How many houses? Hmm? Millions. Okay, millions of houses. That's why. Millions of houses. Industries. Okay, when it comes to industries, I will take some essential industries. Dairy industries. I think food students know very well the thermal processes. What are the thermal processes they are using? What are the thermal processes? Yes. You know many thermal processes in dairy industries. One should be the famous ones. Pasteurization. Okay, so some may be called pasteurization. Pasteurize, let's say. Pasteurize. One of the processes. Even there could be sterilize. Sterilize. For sterilization. Okay. Pasteurization. Okay. Pasteurization, sterilization, and pasteurization is both heating and cooling applies. Yeah. Dairy industries. So pasteurizing, sterilization. So and also you are using heating heating and cooling, refrigeration, boiling. I think food students know this. Even condensation, some adsorption and absorption processes, boiling, condensation, then sometimes heat recoveries and recycling, reuse, heat recovery and reuse. They're using heat exchangers for this. Reuses, recovery and reuse. What else? There should be some more heat recovery, reuse. Sometimes you do use drying, spray drying and all when you make the milk powder. Yeah. Okay. If you use yogurt and all, chilling, cooling, refrigeration, many things. Almost all the processes are thermal. Okay, dairy industries, you can see. Dairy industries, all thermal. So I will add dairy and other food, whatever. Okay, you have everything. Yeah. So even you have food, others, then you have the ice cream also under dairy. Freezing. There are many freezing applications. Okay, lot of freezing applications. So dairy industries. Can you understand? That's why. So even at the kitchen and dairy like this way. So there should be other industries. Let's say dairy and food industry. This. So I'll make it also smaller. Power plants. Okay. Let's say energy industry. Energy. Energy industry. You can see energy industry. This is very important. Energy industry. Ministry Ministry of Power or Ministry of Power and Energy. Yeah. Energy industry. Let's say different applications, but all thermal application. You know, Norachole. Okay? Norachole. Norachole, what kind of power plant is it? Norachole. This is thermal power plant. Okay? Thermal. This is the energy you are using, coal. Okay? Coal power plant. Okay? So coal power. Coal power. So you are using coal power, generate steam, then you run from the steam, you run the generators. Coal power. Then you have heard about another plant these days in the news. Okay? ClnrProdn. Lakdana they call. So ClnrProdn. What power that one? Diesel. Diesel power plant. Okay, ClnrProdn. This diesel power plant. So in both the applications, coal power, you burn, you generate fire first. Out of fire, okay, you create steam power. From the steam power, you turn the electrical generators. Diesel, you create power either in the engines or in the turbines. Okay, you generate power. Also, we have calorimeters. Again, this is something like would be diesel. It is a very old one. Energy industry. So we are discussing only the thermal here. So we have the Lakshapana and all hydropower. Yeah, we leave it aside. Okay. So again, this thermal process. It's the same thermal process. It's the same thermal process. You take this. So you, from this thermal process, you create net work done. Then this work done will be used for power generation. Okay. Then you use for power generation. So this is the same. That's why in energy industry, what matters mostly, it is not about the electrical aspects, but mostly about when it comes to power generation, it is mostly about thermal aspects. Yeah. Thermal engineering aspects. So that is the key. So you can notice that. Okay. Yeah. So there are, of course, in megawatts, in thousands, people are using. Even we don't have, but there should be nuclear in the future. Okay, nuclear in the future. How here? Nuclear. Finally, you take heat or fire from a nuclear fusion. Okay, nuclear fusion. Fusion. Then from there, from the heat, you generate steam. Steam power. Steam power. Then this steam power, we can run the generators. Okay. Nuclear fusion, heat. Nuclear fusion. You generate steam power. Okay. That's why. Now you can see industries. Okay, this is power industry, earlier food industries. And if you think of hospitality industry, hospitality industry, hospitality industry. Okay, you should have this common sense. That is very important. Hospitality. Tourism we call here the short word, but this is more than that. Okay, you know that. Okay, in hospitality industry, the energy consumption. You have air conditioning, because for the comfort cooling, air conditioning. Air conditioning, okay, or air conditioning. Refrigeration. What else? Mainly air conditioning, refrigeration. So are the main, and also there should be for transportation, for logistics. Okay, logistics, hospitality. Let's say thermal. So you are considering the thermal processes. Thermal processes. Yeah. So hospitality industry. This one is hospitality industry. Air conditioning, refrigeration. Yes. Sorry, Buddha. Yeah, thanks for the chapter. Yeah, distilleries. Yeah, no sound. Yeah, distilleries. You can see. So wherever you can see so many thermal energy involved, even in offices, your photocopiers, printing machines. Yeah, it is not about just one piece. Okay, it's about millions of offices. Okay, so that is how the situation is. Okay, Bhutana, yeah, that's how the situation is. So for you, what's the purpose of having knowledge? What is the purpose for you to learn about this? Yeah, what's your point of interest? That is the most important thing. Okay, so what's the purpose of having knowledge of this? Okay, so what is your point of interest of learning those? So what is the point of interest? Interest, okay, for us learning those, okay. What's what's the point of interest for us learning those? So we have to find the answer for this. Okay. What's the point of interest for us learning those? Okay. That is very important question. What's the point of interest for us learning those? Yes, we should consider energy as a resource. Energy is a valuable resource. Is a valuable and limited. Okay, and limited resource. So that is one of the points. Okay, that is one of the very important points. Energy is a valuable and limited resource. This is the point. Energy is valuable and limited resource. And some industries, not to say some, okay, energy is a valuable and limited resource. And many industries, energy could be the key resource, could be a key resource, okay, a key resource in many industries, in many industries. Okay, in many industries. In many industries. That is the reason. Energy could be a key resource in many industries. That is unbelievable. Energy could be a key resource in many industries. So that is the point. Okay, that's the point. In many industries, obviously, transportation. Okay, transportation sector. So without fuel, you cannot operate the sector at all. Airline industry. Okay, airline industry. Airline industry. It's a key. Airline industry. It's a key. Okay, I hope you can understand. That's all. And energy bill in the institutions. Energy bill. Okay, I will write it separately maybe. I will write it separately. Even energy bill is a matter of concern. Okay, even energy bill is a matter of concern. Is a matter of concern. Matter of concern. Energy bill is a matter of concern. Dairy industries. Energy is an issue. Dairy industry. Okay, dairy industry. So I can put dairy here maybe. Dairy. Dairy-based industries. Dairy-based industries. Or industry. And there should be many things. Many industries. Okay. Yes. This energy is the key. So having learned this, what makes this your concern? What makes this your concern? Yeah. So this really has an effect. Okay. This has an effect, direct effect on the profit margins. Profit margins has a great effect. Profit margins. Okay, effect on the profit margins. This is quite significant. And the logistic challenges sometimes, yeah, energy related logistic may be challenging. Okay, effect on the profit margins. Then environmental concerns. Okay, environmental concerns. Concerns. because of emissions. Okay, emissions such as CO2, SOx, NOx, and even the heat losses. Emissions. And even the heat losses. Sometimes heat loss can be thermal pollutions. Okay. Sometimes heat losses could be thermal pollutions. Okay, heat losses. Yeah. So what is the point of interest? So we outline these things. How come these become point of interest for you? Yeah, because these are the potentials for you to contribute. That's why these are the potentials for you to contribute. Okay? Heat losses and all are the potentials, are the potential areas, are the potential areas for you to look for. Okay, look for answers, innovations, okay, innovations, and opportunities to contribute. Okay, to contribute. So that is the point for you. Are the opportunities for you to contribute, for you to contribute. Okay, so that is very, very, very important. Okay, that is extremely important. Yes, you will see the opportunities. Yeah. That's why your interest, your sense of interest is very important for energy. Yeah. So when you see the electricity bill of your organization you are joining, when you see the thermal processes, once you see the thermal processes, you should know that it is costly and it consumes resources. Then look for alternatives, energy saving, energy recovery, recycling. These are important. Okay? These are the opportunities for you to contribute. Yeah, even when you go to interviews, yeah, you can talk about this energy. So you will look for some energy consumption, optimizations, energy recoveries, and reuse. These could be your interests when you are joining companies. Or even you can provide any energy solutions as a business. You are initiating. Okay, that's why. So energy sector is one of the key when it comes to the businesses and entrepreneurships. Energy sector is one of the key. Very interesting. Okay. Yeah. So I believe you got some connections of this thermal energy processes. Of course, there are plenty of thermal energy processes, but whatever mentioned here, you get this connection of the thermal energy processes with the subject. I believe so. Okay, with the subject. I hope you got the connection. Now let's see. What are we going to do, or what are we going to improve? Let's see. What are we going to work on this? Yeah, even for the exam, it's very nice to have this kind of questions to be in the question paper, thermal processes. Now, you can think of the directions, maybe process innovations. Okay, for management students. Yeah, keep in mind. Yeah, you can give the ideas or you can give the directions. Okay, process innovations. To minimize okay, process innovations to minimize what? Process innovations to minimize thermal process innovations. Maybe for the similar outputs, when your process you innovate, your Q in will be minimized. Yeah. So saving of energy, saving of resources is a good managing of energy. Yeah. Process innovations. That is one point. Process innovations. Yeah. To minimize Q in, also other way, process innovations to improve or maximize. Okay, maximize is not a bitter word, but improve is better. Okay, improve what? Improve your output. That is also better. You are improving the output. Same Q in maybe, but you are maximizing the output. Yeah. Maybe possibilities. Yeah. So here Q in for the same output. Okay, W net or Q net. Here process innovations to improve W net or W use for Q net or Q use. Okay, or Q net or Q use. Or else Q net or Q use. You can improve. Okay, Q net or Q use. That is very important. QNet or QUS. Very interesting. Yeah. So your output improvements. Okay, to improve output. Okay. Output. Yeah. Process innovations to minimize input. Input even could be a single word. Output could be a single word. So you improve output or to minimize input. So both improves what? Efficiency. So improves efficiency. Both improves both improve efficiency. You can see when you minimize the input or you are maximizing the output. Yeah. To improve output. Both really minimizes the losses. Both minimize loss. Okay, minimize. Minimize. Q loss. That is what the both results. Minimize Q loss. Yeah. So enhance productivity. Okay. So improve productivity. Improve productivity. Okay. Or efficiency. So that is what is done by means of this. Improve productivity and efficiency. That is very, very, very important. Okay, that is very, very important. Yeah. Now I'm going to talk about the recovery and recycling. Recovery and recycling. Yeah. About recovery and recycling. Let's say there could be technologies where this Q loss, you won't let this Q loss to become a loss. Okay, become a loss. Perhaps you may be taking some portion of this out. Taking some portion of this. You're tapping this. Okay, you're tapping this part of heat not to make it totally a loss. Okay, maybe you're tapping this part. And perhaps this one, this portion of the energy you tapped, probably you are bringing back to the process. Okay, you are bringing back to the process. Very interesting. So you are recycling, recover and recycle. Okay, you recover and recycle. Yeah. That is a very important aspect. Okay, so recover and recycle. There should be a portion. You are recover and recycle. QR. Let's say we got QR. What happens now? Because you recover this and recycle QR. Interestingly, when you have this, your total is Q in, true, Q in. But what happens is, when you recover and recycle, this Q in, move it further to get some space. It's the same thermal process. You need Q in, you need Q in, but now there is a part recycle as QR. So now what happens is the real input is Q in minus, okay, minus interesting. QR. Yes. Now this is the input. This is the input. Q in minus ER, QR. Because that is the new Q in, because you are recovering this. Okay, you are recovering the loss. Very interesting. Yeah, you recover. Okay, you are recovered. So your input is the same for the process, but need from the outside is need externally is Q in minus QR. Very interesting. Q in minus Q. This is what the new Q in. Q in in new. Okay, Q in new. See, it is less because you are recovering portion back. Okay. You are recovering portion back. Yeah. So these are the process innovations. Okay, here to minimize. Okay, minimize. Again, of course, it is input. Q in. Here, it is based on the energy recovery. Okay, process innovation. To minimize inputs through energy through energy through energy what recovery and reuse. Okay, recovery and reuse what energy. So this is very, very important. Energy recovery and reuse. So those are technology innovations. Okay, technology innovations. That's why. So these are points for you to explore. Okay, these are the points for you to explore when you are really in the field. Okay, when you are really in the field. Energy recovery and reuse is how to say is very advanced technology nowadays. They can recover some cases even over 90% energy. They are recovering because now energy is costly. Energy is money. Now energy becomes environment. Okay? Energy becomes profit. Even some businesses, energy saving may be their profit. It is something like that, especially in the airline industry. Energy saving is very sensitive for the airline industry profit. Surprisingly, this is the situation. Airline industry. Surprisingly, that is the situation. Okay. Energy recovery and reuse. So you have QR here. Okay, QR. Very important. So we have learned a lot now. The approaches: minimize Q in, improve output, minimize loss, improve efficiencies, recovery and reuse. Now what happens is your efficiency, okay, is now, it is something like your Q loss. Now the efficiency, let's say if you take the word efficiency, it may be a new efficiency term now. It may be a new efficiency term. Let's say I make it a little big. Improve efficiency. Now Q in new. See, Q in. Now you have new. Is a smaller value. Q in. Q net. Yeah. Example here, the 1 minus Q loss divided by Q in new. Yes. Now here Q in new minus Q loss divided by Q in new. So you have internally Q in, but to the process, the energy input from outside is Q in, all replaced. Okay, all replaced. It's a new definition. That's why energy recovery and recycling. So this is also process innovations. Yeah. So minimize, not to say Q loss, but yeah, you improve the efficiency through the recoveries. So very, very, very important. Energy recovery and recycling. And this is one of the areas people are focusing. One of the areas people are focusing, reuse, or we call it recycling. Okay. So let me draw one more, the same one. I will duplicate this. Perhaps you have tapped, but out of that, okay, out of that, you may be using the portion for different purposes. See, your Q loss is here, it is reduced now. Q loss is reduced. Okay, now I'm going to improve this diagram. So what happens now is, I hope Utala you can understand this. This is your Q loss. Anyway, we are meeting after second in the classrooms, so we can discuss this in style. Q loss, out of Q loss, you are using portion, and some maybe this is QR, this is another QR. Okay, I will use this as reuse. reuse, Q reuse. This is Q reuse. And this QR is actually recycle. Okay, you're cycling it back to the same process. So that is the difference of reuse and recycling. But both here we are recovering energy. So one case recovery and reuse, another case recovery and recycle. So what happens is now your Q loss new. Same like Q in new, you have Q loss new. Okay, you have Q loss new. Q loss new. Okay, you have Q loss. Okay, you have Q loss. Q loss new. That one is equal to what? Q in new minus, okay, Q in new minus Q in new minus, you have Q recycle here plus Q reuse. Q reuse. Very interesting. Actually, these are not the just simple concepts, but these are true concepts. Okay, these are true. The practical aspects are there. Okay, practical aspects are there. See now, reduced Q loss, Q in new, and also you have reuse and recycle. Reuse and recycle means, what is reuse and recycle? Q recovery. Okay, Q recovery. Is reuse plus recycle. Okay, that is very important. And as a result, let me duplicate the slide. As a result, you can see here Q loss new means Q in new minus Q recovery. That's why recovery is nowadays very important in energy applications. Okay, so in energy saving, energy recovery is something very important. Okay, energy recovery is something very important. Yeah, very good. Energy recovery is something very, very important. So you have a new efficiency terms. Okay, new efficiency terms. So your efficiency become 1 minus Q loss new. Now you have Q loss. See, Q loss new. Divided by Q in. Okay. That's how the efficiency term becomes. That's how the efficiency term becomes. Now, so we have the concept, the basic concept of energy recovery and recycling. Okay. Now you have the idea. You have the idea. Very good. Okay. So this is the energy improvements because of recovery and recycling. Good. Energy recovery, reuse, and recycling. Okay. Good. Recycling it is not only the waste, okay, material waste, but energy. You are not let the energy to waste. Instead, recover, recycle. Yeah, okay. I have a little confusion here. In the waste, recycle means you collect it and then you recycle. But here, how to say? I put recycle here instead of reuse. Yeah, recovery and recycling. Yeah. Recovery is here, reuse is here. Recycle and reuse. So this is the recycling generally in the sense for energy. But for material, this may be... Anyway, it's okay. You have the concepts. Well, you have the concepts. Even reuse can be here, recycle can be here, but I hope this is okay. I hope this is okay. Yeah. So very good. Now I'm going to open a web page. Okay, a web page. Let's say I'm going to share this. to explore energy recovery and recycling. Even in hybrid vehicles, the technology is, you can see the pages, see results. I think it's over 100 million websites, maybe, I don't know, 10 million websites. Energy recovery, recycling, energy recovery technologies, energy recovery from blast. You can see this is nowadays a very important technological aspects, but mainly because of environment and also as a purpose of resource management and also by considering the cleaner production. Okay? For cleaner production receives reduced amount of energy and produce less waste of energy. And also they are using clean energy and they have no emissions in clean energy when it comes to the cleaner productions and also for environment management. So anyway, recycling is a very important point. Yeah. So energy recycling, even sometimes you are using, how to say, sometimes you are using for recycling, example, you use material, example, plastic. Maybe you burn it properly and you generate heat. And you are using that heat back in application. See, material converts to energy. Also possible. Sometimes incineration means burning of waste. You may be using for power generation. Possible. Sometimes biomass. You are using biomass means digesting the biomass and the producer gas, and you use that biomass produced gas for power generation. That's why. That is some other applications. So anyway, when it comes to environmental management and cleaner production, energy and especially thermal energy is a very important aspect. Yeah. So that's why now you can see with some available knowledge, you can find some good directions because you have some sense of this knowledge. So when you go to the industries, you know where to contribute, at least where to identify the opportunities, okay, to contribute. So that is very important. Now we are even doing one project here, manufacturing students. They are doing, let's say, example, burner development. So efficient burners, sometimes, yeah, you can develop more efficient, clean burn for clean energy application and also for efficiency improvement. So then your energy input is less. Yeah. And your emissions are not there and your net out is more. Yeah, that's why. So the new technologies for the burning, combustion, new technologies. Those are the things really brings the innovation towards this direction. That's why there are energy researchers on God. Energy research. Energy research a lot. Energy means not only the thermal, but can be solar, it can be other technologies, but thermal energy is one of the key factors, one of the key factors in energy and environment related to industries. So I hope you can understand this better. If in the classroom we can discuss this very nicely, but here in the Zoom sessions, yeah, we can share, but it is very hard to see you and how and to get feeling about how good you are understanding. That is pretty tough here. I don't see you. You don't see me. So little less understanding, but anyway, we are trying our best. So that's why your attention is very important. And later I will share this PowerPoint with you right now, maybe. I will share this PowerPoint right now. So today our discussion is only about this thermal processes in general. So that's what we have done so far. And even if you think of the new automobile technologies, let's say the hybrid vehicles, hybrid engines. Yeah. So hybrid. So you have to understand what hybrid means as well. What hybrid means as well. The hybridized solutions, hybrid vehicles, hybrid engines. So those are the technologies. What hybrid engines done? Hybrid engines. Okay. Let's see what happens there. Hybrid engines. So what happens is, so focus on the diagram. Focus on the diagram. Yeah. So engine, you have energy input. Okay. Somehow you need energy input for engines. But what happens is, you have the battery. You have the battery. Okay. I put Q battery here. Q battery. Q battery. So you are receiving some energy from the battery. So your Q in as petrol become reduce. Yeah. Sometimes it is running totally on the battery. Yeah, literally, of course. Then you are not to say engine, you have to have the engine plus the transmission, because battery means it is not driving the engine, so that bypass engines to transmission. Transmission is here. Transmission is here. So anyway, here the if the output is Q battery is here, good. Let's say this way. I have to change all. I have to change all this way. Let me draw. Correct me if I'm wrong. Huh? I don't know. Correct me if I'm wrong, because you are experts, not like me, when it comes to vehicles. Yeah. So you are receiving energy from battery as well. Okay, energy from battery. So somehow it is charging. You are using the wastage of something to charge. So then your battery is in. Q in is this, but Q in new is because of this battery. you are using less energy because of this. Now, battery is here. Battery has its own efficiency as well. Anyway, your transmission is here. So it's some complications are there, not exactly this. What was the previous? Why not? I will use the previous one. So this one. I take this way. Anyway, so just pass here. This way. So Q in is Q in minus QB, Q battery. I don't know. This may be right sometimes. This needs some little rectifications, but okay. Not to say totally some issues, but anyway, this has some sense. Okay, Q in becomes, yeah, because of this Q battery. Sometimes, yeah, for the losses you are charging, sometimes even losses you are charging, sometimes even externally also you are charging. Let's say when the vehicles are moving downhill, okay, downhill, maybe when you apply brakes and all, yeah, anyway, other than the losses, there would be some other inputs, like when the engine running on, how to say, low gears down the hills, maybe engine is just moving with no power, somehow the battery charge is possible maybe. It's moving like this. So here there may not be reuse here. So I take this. So this is external, okay? External energy Q. Other, I just put. Also goes to battery. Loss also recovers battery. So we have other, even the electric charging or whatever, even the vehicle goes downhill. So you can see Q loss, Q battery, all. Then the battery got more power. In some instance, it's running totally on battery. And then the Q in may be zero sometimes possible, because if Q battery is equal to what's W net needed, Q in can be zero. With just a schematic, just a schematic. This one. So don't be very serious on this. Yeah, just a schematic. Okay, schematic. Hybrid vehicle schematic. Not a perfect one. I just draw this vehicle. Vehicle. Schematic means it is not perfect. Eh? It's not perfect. You have to do analysis as well. schematic. You have energy recovery for sure. Recycling, sure. Reuse also there. Technology innovations. Okay. Schematic. Okay. Technology innovations. So sometimes maybe other means can be solar, electric, or the momentum of the vehicle may be down the hills, extra kinetic energy. You are converting for the battery storage. Yeah. So other sources of energy. Okay. Yeah. Interesting. I think this is quite explainable. Okay, battery just moves like here straight to output. Okay. So there can be devices here. I put that device. Maybe through the motors, maybe through other controls. You have different technologies. Even there could be different.
Excuse me, sir.
Oh, yeah, Buddha.
The slide is not showing.
Sorry.
Presentation slide.
Okay. I'm very sorry, Buddha. Yeah, you are seeing it. Is that so? No? This one? Is it okay? Yeah, Buddha. Below? Yeah. So this
Sir,
way.
now
Now, okay. So that's how. So you can balance this kind of, you can recognize. Few other even can be some cases like solar. You can add solar or maybe plug-in vehicle or maybe tapping some other losses or whatever. Anyway, Q losses here. So tapping. So your Q loss net would be now different. Q loss new. You have Q loss new. Q loss new. You have the reduced Q loss. It's very interesting. Yeah, that's all. So here you have a reduced Q loss new. Yeah, reduced Q loss new. Yeah. Interesting. Interesting. Good. So this will new Q loss. It's reduced. Instead of new, we can mention maybe reduced. QA reduced instead of new. Reduced is a good word. QA reduced. Yeah. New means reduced. In new means reduced. With this improvement. So in hybrid battery, this may be hybrid engines, whatever solutions. So you can look for separate technology. Now see, you have the engine technology and you have battery technology. So of course here hybrid engines, you have the engine here, the battery here. So combination of this contribute for the same cost. That's all. Engine and battery combined. So it is good. So one day maybe this battery can replace the engine fully if the battery technologies goes further in advance. The battery technology still has some issues. One example is if caught fire to this battery, this is lithium-ion batteries, if get caught fire, it is impossible to extinguish the fire. It's a very violent chemical reaction. So lithium-ion battery explosions, there are no chance to extinguish the fire. Malaysian Airlines, China in the line flight, one from Kuala Lumpur to China, Malaysian airline flight, halfway it was disappeared. So far, I think still people didn't know what happened. But even there were lithium-ion battery, a load of lithium-ion battery on the cargo. So that's why afterward, passenger planes have stopped carrying lithium-ion batteries. There is a risk. Even, can you remember recently this Anuradhapura case, one SF Lokawa, the fire, battery caught fire. So even the fire brigade came, but still it couldn't burn, couldn't extinguish it, totally burned. The reason is the lithium-ion battery, it is quite explosive. So you have to be, not to say very careful, but it's a concern. Yeah, it's a concern. If get caught, lithium-ion battery, if catch fire, it is impossible to extinguish. Even controlling the fire is very difficult. So there is a risk of that. So once these kind of things are resolved, and this battery technology is common, I think this will be quite revolutionary in the automobile energy sector, as well as in the other energy sectors. Yeah. Good. So today we have learned about energy recovery, energy recycling, and energy reuse. And one of the huge application of this, of course, a lot, not to say it is huge, but let's say the regenerative thermal oxidizers. These are also consuming fractions of megawatts, but there are thousands. So these are really the consuming energy is that much, and those are huge. Yeah. So let me play one. Okay, I have to change the screen first. I have to change the screen first. Let's see if I play a video or if I just show you a picture. I think picture's okay. Just so that you can see here. This right side in your screen. It's a huge energy recovery unit with combustion. Okay, with combustion. So recovery and recycling. Here also recovery and reuse schematic combustion. That's why this is in the industries, even in printing industries, you have to have this, especially in lake house and all printing big institutions, industries. There should be uh, this thermal oxidizers, because otherwise it's not good for the environment and human health. But in Sri Lanka, unfortunately, still no such solutions are being there in the industries. Let me show you, if possible, a video. And those are only big companies they are doing. US, Germans they are doing. Taiwanese, even Japanese, Chinese, they are in, but even in India, they don't have this program. So that's why, but now because of the expensiveness of energy, this is a 2-minute one. Yeah, I think that is not much better. So you can see this energy recovery and recycling is very important. So that is what I have learned. Uh, so you know what's the objective of learning this. This is very relevant from this environmental management and clean production, even for sustainable consumption and production. This is very useful. And after having this knowledge, you can think of innovations. That's right, technology and also operational, the innovation is very important. Even you can think of designing, outlining solutions. Yeah, this is very important. Yeah, you can think of innovations. Yeah, that is very, very important. Try to look into innovation. Yeah, that is very important. Bring the innovations to energy sector, thermal sciences, thermal processes. So this innovation is extremely important. So you can design, when you design the components, now we have some basic sense of the importance of energy. Saving, efficient use, energy recovery, reuse, recycling, and all the things. Yeah. Basically, you know this. Yeah. So this is very important. So if you have industrial questions, we can discuss. Sometimes in B2 students, they are from the industry, they are really discussing the things about the thermal processes, how to improve the things, some designs. Yeah. People are discussing. I can notice that B2 students, they are very keen on practical issues and practical aspects. Anyway, don't worry. You are still young. You can gain a lot even in the industries. But here, it is very good to have this sense of energy recovery, recycling, and reuse. So I have no plan to spend another day for this. But here, heat energy, environmental, clean energy, renewable energy, cleaner production, sustainability and economy. This area is not has not been covered still in the class because this is a huge area. So we have to discuss. It should be in this dialogue, should be with the dialogues. So probably we see how to gain more knowledge in the coming sessions. But we have done plenty of the things. So you explore this maybe by yourself. I'm not giving any assignment at the moment. So later I will try to pass you some assignments. Okay. That's all, Vitala. So any questions before stopping the class? Hope you have gained something. This picture. Hope you have a very good photographic memory of this kind of things. Yeah. And connect this with your practical sensors, practical examples, applications. Yeah. At least you have some applications known to you. So connect this knowledge and see how important this in environmental management and clean production. Okay. Energy is, of course, and this is quite related to economics because boiling water happens in each and every house. Simple like that. So that this is really related to economics, not only to technology. Okay, Bhutala, let me stop the class then. See you next week. I can see some chat. Screen is not safe. Yeah, I hope you see the screen. Yeah. So look into the. Yeah, I think it's time to share this with you. Let me share this. If I save this. I save as energy presentation. Energy presentation. Yeah. Let me email this to you. Okay. PDF. This is here for you. PDF. Energy presentation. Give me a second. I'm going to email you this one. Let me email you. Attachment. Documents. Energy presentation PDF. Okay. Recipients. L. H. Today. Okay. I just said it. That's all, Bhutana. So let me stop the class now. Tell me whether you have received it or not. I hope you have received it. Okay. And let me stop the class there. Bye then. I'll see you after.